When my ESP32 first boots up, it goes right into provisioning mode. It shows an SSID we can attach to and an IP address at which we can access a web page. When I click this icon, my laptop automatically goes to that SSID, opens a browser, accesses the page, enters credentials, and saves them. The ESP32 connects to the internet and continues on with its tasks. We're finally here, the one-click provisioner. I have been waiting a while to make this video. Of the things I've showed you, this may be my most original work as it relates to provisioning. It may seem that the purpose of this tool is to, in production, be able to quickly provision devices that you're bringing online or when you're replacing them. That is true, but the actual inspiration for this technology was the pain point of, while developing my provisioner, having to open up a browser and enter data each time to continue on and see if my code was working. If you're developing your own provisioner, you're going to want to have on your desktop an icon that you can click every time. When you burn new firmware, click the icon and you can confirm that it provisions. That's why I made this code. So this is really more about your development toolkit than it is firmware. I'll do this opposite of how I usually do it. I'll create the repo first, then I'll clone it into my folder and start working in that folder. That way I don't have to set the git remote URL later. We're going to create two folders, app and provisioner. Provisioner is going to be a copy of that ESP32 code we've been using for the last several weeks. And our app will be a Node.js app that automatically fills out our provisioner page for us. If you're currently programming your microcontroller in C++ and you're not familiar with Node.js, do not be dissuaded. This code is so simple, you will absolutely be able to use it. You do have to have Node.js installed on your computer, however, for this to work. The starting point for any Node.js project is npm init and then -y to automatically step through the optional data provisions. We're going to install Puppeteer. This is the library that's going to allow us to programmatically attach to Chrome and control it. You look in package.json, you see there's the Puppeteer installation. We'll run everything out of app.js. We'll create a Puppeteer object using the library that we installed. Now, I have a personal style choice here. Whenever I have a simple program that needs to do something asynchronously, I always just create an async run function and then call it. Once we set up this browser object, I want to call node app to run the program and see what happens. VS Code provides us a terminal window, but I don't like the syntax, so I'm going to use my git bash window here instead to call node app. Nothing happens because, by default, Puppeteer runs in the background. We hit Control-C to cancel. You need to tell headless false. It defaults to headless true, but headless false brings up this big white screen because it's an uncontrolled instance of the browser that just opened. I learned Puppeteer before AI, so I don't know where I got this, probably Stack Exchange. But in the docs, I didn't see how to set a window position. I do know that this syntax works. Be careful not to put a space after the comma. That will break the API. I picked 440X and 310Y, and you can see that gives me a browser window that is positioned just inside the window that I'm recording. So that's how we position our window. As it relates to sizing the window, I want to go to the Puppeteer docs. There are a couple things here I don't think I agree with. The viewport is the size of the canvas inside the window. It's not window size. Window size is what we care about. So I go with default viewport null, and then I set as an argument the window size here. This works. So there's a pretty well-sized window. There's one more thing in the docs I don't really agree with. After you bring up your browser window, it recommends that you await a new page. I'm confused by this one because no matter what you do, whenever you bring up a new page, you end up with two tabs in your browser. The only solution I got to this is to grab not a new page, but all the pages, which returns an array of pages, and then you grab the first one, which is index 0. This will give you one tab in your browser. Now we've reached the point where you can finally understand why we're playing with this Puppeteer thing. It's because we can actually access websites and control them using this program. So now we've programmatically pulled up Google, And no, we're not interested. We're not here to access Google. We're here to access our provisioner. I created this folder in the beginning, but we didn't pull down the provisioner. I'm going to get the provisioner from the second video we did. This would be about 3 or 4 weeks ago. This is a simple program with a formatted provisioner that runs the provisioner every time you boot the device. We're not storing our credentials yet. This is more an exercise in checking that we have a running provisioner and that we can fill it out and get our device to connect. I'm going to delete some things we don't need here. A link is in the upper right for the video that produced this code. You don't need to understand everything about it. You just need to know that it's going to serve a web page that has inputs, 2 inputs, one for SSID and one for password. This is the page we're going to have Puppeteer access and then enter credentials into it. In the second video I just linked, we viewed the pages in a browser by dragging them from Windows Explorer. Here we got to do something different. We're going to have our Node.js app call these web pages, so they need to be served with an actual server. If you have Python installed, this one-liner is my go-to for just getting a quick server up. We'll serve any pages in this folder with that Python command. There's our config page. Here's our saved page. We want this to be running so that our app can hit this localhost 3000 and pull the config page that's in that folder. Run the app again, and you get the config page. Let's open this up here. If you hit F12 in Windows, that gives you the dev tools. The command is different for Apple. It allows you to inspect the page and pull out certain details. For instance, we click on the input and we see that it has an ID of SSID. We can access that input programmatically. This page.waitFor selector will pull until we get an element that has matching CSS. Then we can grab the element that has that CSS and write this string into it. This seriously works, gets written into the input. That's not fun though to have it written instantly. Let's put in this slow-mo. This is a cool feature. Watch what it does now. It simulates typing. That's a little slow though, so I will reduce that to 10 for the next one. Now I'm installing .env. We're going to use this, there it is, because we want to keep our credentials in a separate file. When we require .env and then run config, it's going to pull in the values that are in a .env file, and then we can use those values in our code. We want to create a git ignore so that the .env file does not go up to our git repo, so the credentials are held just here on our computer. Now we can access those values with process.env. Wi-Fi SSID and Wi-Fi pass. We've got 2 inputs, one for the SSID which we're already using. We can add the password input as well. And with that, we can fill out both inputs. What happens when you click save? You get this error because the server isn't exposing the route that was called by that button. We can add a line though anyway to our code. Again, this is a CSS selector, an input that has a type submit. Puppeteer will look for the first instance of this, and there's only one, so it'll find our button. And then when we run through our app, it fills in the credentials and automatically clicks submit, as evidenced by this same error. Looking back at our provisioner, there's 2 key pieces of information we need to make this work. The first is the SSID that it exposes, and the second is the IP address of the server that's launched. We can go back to our app and add the IP address, and now we're going to access the base route of that provisioner. So here's our provisioner again. We manually access this SSID on our laptop. and then run the app. Because we're attached to the network of the ESP32, and it goes and grabs that page, fills out the credentials, and the ESP32 connects. That works well, except we had to manually grab that SSID. Is there a way we can do this automatically? There is. Netch. If you just type this command and give it the SSID, it will fail the first time if this profile does not yet exist in your network settings. But once you've connected on your laptop or computer or desktop and the profile has been created in your network settings, we can then use this command to connect. Notice we're in our app folder, so if we run app, it connects to the ESP32, runs the page, and provisions it. So now the only thing to do is to take this netch command and combine it with our Node app. Before we proceed, when we're done running our app, we can also call browser close. And by the way, we don't want to call that immediately. We want it to stay open for a couple of seconds so that we can see the success page render. I'll create a bash script that calls both those commands. First, we run our netch command, which attaches our computer to the device provisioning SSID. Then we simply run node app. Puppeteer will take over, we'll grab that page, enter the credentials, and the device provisions. Rearranging our windows here, provisioner's up. We've got our bash script right here. So if we run it, the device sets the computer to that SSID. It hits the server, pulls the page, enters the credentials, and it provisions. So now we can provision the device by simply calling that bash script. But how do we make it one click? By creating a shortcut to the bash script. I'll do that here. Although the working directory was specified in that shortcut, it didn't respect the path when the code actually ran. So I'm going to hard code the path to our app. And now let's rename it provision and give it a cooler icon than what we have. I'm looking for the key. There's something like a key. We get the logs opened up here from our ESP32. We click the button. It steps all the way through, saves that page, ESP32 connects. We just got a one-click provisioning. We can speed it up a little bit. I'm going to drop this last sleep 2. We don't need to see the page because we're going to go headless anyway. Slow-mo will get faster. And then we drop the headless false. So we're not even going to see the browser. Let's reboot the ESP32. Goes back into provisioning mode. Hit the button. Done. Connected. That shaves a couple of seconds off it. This is my 15th video this summer and the last one that will be coming from Seoul, South Korea. After this, I'll be back in Ohio. I said before I would go MQTT and then Raspberry Pi next. I think it's actually going to be MQTT followed by IoT dashboards using HTML. If those topics interest you, subscribe to stay apprised of these tutorials as they come out. And if you found this content helpful, remember that clicking like helps YouTube promote to others, and it does also help me. That's it. We're done with provisioning. Time to move on to MQTT. I'm Larry. I'll see you in a week.